So now we're going to solve a few linear inequalities. The main thing to remember that's different about solving an inequality than an equation is that whenever we multiply or divide by a negative number in an inequality, we have to flip the sign of the inequality. But if we multiply or divide by a positive number, we don't change anything. So we'll see this as we do a few of these examples. I'll point it out as we hit it in the problem. So we'll start with this inequality. 5x plus 2 is less than 12. So I'm going to solve this the same way I would solve the equation. I'm just going to subtract 2 first. So subtract 2 from here. That will cancel out there. But I also need to subtract 2 from the right-hand side. So I end up getting 5x is less than 10. And now I can just divide both sides by 5. Now I'm dividing by positive numbers, so we don't change anything. The 5 cancels out, and we just get that x is less than 2. Now what this means is that any x value that you pick, not including 2, but any value that's less than 2 that we pick on a number line should be a solution to this equation. For example, if I pick x equals 0 and plug it in, this should be a true equation. I should say our original, not equation, but inequality. This should be a true inequality. So 5 times 0 is 0, plus 2 is 2. That is definitely less than 12. 2 is definitely less than 12. If I pick a number like x equals 1, 5 times 1 is 5, plus 2 is 7, and yeah, that's definitely equal to 12. But if I pick anything greater than 2, for example 3, 5 times 3 is 15, 15 plus 2 is 17, which is definitely not smaller than 12. So you can see how all of the values working here make this a true statement. And in fact, we don't have to just pick whole numbers. We can pick fractions, decimals, whatever we want to pick, negative numbers. They should all make this true as long as they're in the solution of the inequality. We'll try a different one. So negative 3x plus 2 is less than or equal to 7. Again, I'll subtract a 2 from both sides, so I'll get negative 3x is less than or equal to 5, because this 2 cancels out. And now I'll divide by negative 3 to get rid of that negative 3 on both sides. However, I have to be careful here. Whenever I divide by a negative number, I have to switch the sign. So this less than or equal to will become a greater than or equal to at this point. This is the tricky part that you have to make sure you remember. So in this case, x is greater than or equal to negative 5/3. All of those x values will serve as solutions to our inequality. So anything from negative 5/3 and up will work as a solution to this original inequality. Sometimes we can solve an inequality or two inequalities at one time by combining them into a compound inequality like this. In this case, I'm still trying to solve for x, but anything that I do to the middle of the inequality, I need to do to all three sides, since this is compounded into one thing. So, for example, if I add a 9 here to cancel this 9 out, and I only have to add a 9 over here, but I also have to add a 9 over here on this side of the inequality as well. So I'll get negative 6 plus 9, that's equal to positive 3. The 9 cancels out here, so this is just 3x, and then this is less than 0 plus 9, which is just equal to 9. At this point, I'll divide by a positive 3 to cancel out that 3. Then again, I need to do this to all three sections of my inequality. So 3 divided by 3 is 1, so that's less than or equal to x, which is less than or equal to 9 divided by 3, which is 3. Now, again, remember the reason I didn't have to flip my signs here is because I divided by a positive number. We don't have to change anything. We can keep it exactly the same, so we're good to go. We'll do one more like that. Negative 4 is less than or equal to negative 2x, which is less than or equal to 12. In this case, the only thing we need to do to get the x by itself is to divide everything by negative 2. So if I divide by negative 2 here, that will cancel out. Divide by negative 2 here, and then also right here. So 3 different places. Negative 4 divided by negative 2 is 2. And then I have to flip this sign from less than or equal to greater than or equal to because I divided by a negative number. And I have an x right here. This less than or equal to also becomes greater than or equal to. We have to flip all the signs in the expression, and then I'll get a negative 6 here. So this is saying that x is greater than or equal to negative 6 and less than or equal to 2. So if I were to look at it on a number line, here's my negative 6, here's my positive 2. All the numbers in between negative 6 and positive 2, including 2 and including negative 6, they should all work as a solution to this inequality. So any number you pick in here and plug it in for x into the original inequality should give you a true statement. Anything that you pick outside of the shaded region and put in for this inequality should give you a false statement.